Hello, today we're going to start chapter 11, but before we officially start it, we're going to do a little bit of maintaining mathematical proficiency because we need to talk about mean, median, mode, and standard deviation. So this graphic is taken from your Algebra 2 textbook if you want to find it at the beginning of chapter 11. And hopefully you remember mean, median, and mode. So there's another name for mean, and it is average. And how do we find an average? You're going to add them all up and you're going to divide by how many there are. So another thing though that you need to take note of here is this little guy. He's called X bar because there's a bar on top of him, and he is the symbol for mean. So sometimes we use that instead of spelling out the whole word. Up next we have median, and median is the middle number. I always remember the middle of the road is called the median. If you happen to have two middle numbers, you're going to add them together and divide by 2. You're taking the average of the two middle numbers. And mode is the number that occurs most often. You can have multiple modes, but they all have to occur the same amount of times. So we're going to look at the maintaining mathematical proficiency problems in your math journal now if you want to head there. So looking at number 1 in your journal, we're going to find the mean, median, and mode of the data. I do usually find it much easier to work with data when it is in numerical order. So the first thing I'm going to do is I'm just going to rewrite it. So 21 goes first, then 24, and I'm going to cross them out as I go here. 26, 26, 32, and 55. One recommendation I usually make to people is to count how many numbers you just wrote, 1, 2, 3, 4, 5, 6, and how many numbers that you started with, 6, just because sometimes it's super easy to forget a number along the way. Alright, so first of all, if we want to find the mean, just because it's listed first, so the mean is X bar, and we're going to add up all the numbers. Okay, so I have my calculator here. I'm going to do 21 plus 24 plus 26 plus 26 plus 32 plus 55. That answer is 184. I'm going to divide it by 6 because there are 6 numbers there, and that gives me 30.67. It's actually 30 2/3. Okay, up next we're going to find the median, and the median is the middle number. So since I have 6 numbers, since I have an even amount of numbers, there's 2 middle numbers. And if I add them together and divide by 2, I'm going to get 26 because they're both 26. So the median is 26. And then the mode is the number that occurs most often. And the mode also happens to be 26. Now something about these, they're all called measures of central tendency. So all 3 of these are measures of central tendency. They should tend towards the center of the data. And so sometimes though 1 or 2 might be better than other ones. They might be more centered. And then also the bigger your data set, the more centered they should be. So here we have 6 numbers, and so it's not a huge data set. So we have determine which measure of center best represents the data. And really we're looking at 2 of them. These 2 best represent the center of the data because that is where the center of the data is. The mean is a little on the high side, and if we look at it, it's because this 55 pulls it higher. Okay, so when you look at mean, median, and mode, they should all be towards the center of the data, and in this case our median and our mean are the better of the 2, or better of the 3. Okay, back to an example from your textbook. We want to find standard deviation, and standard deviation might not be something you have found before. So for those of you who have not ever found standard deviation before, standard deviation pretty much tells you the average distance every data point is from the average, like the average from the average. Okay, So to find the standard deviation, you first need to know the mean. So to find the mean, we're going to add up all of our 8 numbers, and here we have them listed over here. So we're going to add up all 8 numbers. We're going to get 96. We're going to divide by 8, and our mean is 12. So if you want to organize your work into a table, here's our original 8 numbers, and then our mean is 12. So the next thing you're going to find is you're going to do x minus x bar. And x are your original 8 numbers, and then x bar is your mean. So if we do 10 minus 12, we get negative 2. 2 minus 12, we get negative 10. 6 minus 12 is negative 6, etc. there. What you're going to do next is you're going to square those differences. So we're going to take the number we just found and we're going to square them. Then what you're going to do is you're going to find the mean of these. So these are called your squared deviations. Deviation is just how much you differ from, how much away is it. So these are your squared deviations, and then we're going to find the mean of the squared deviations. So you're going to add up all these numbers. So we should have 370, and you're going to divide by 8, because there's 8 numbers. You get 46.25. So the next thing you're going to do is you're going to square root that. So you're going to use a calculator to square root it. So what we have down here, this is actually your formula for standard deviation. So that's the part that we need. Okay, and we just took it one step at a time. We found the means, then we found those differences, then we squared them, then we added them together, then we divided by how many numbers we had. Okay, so we've done this one step at a time. So when we square root 46.25, we're going to get about 6.8. What this number tells you, and you will usually be at like interpret the standard deviation. This number tells you that the data typically differs from the mean by 6.8 units. So like on average, the data points, these data points, are 6.8 units away from the mean. Does that mean they're all 6.8 units away? Like 10 is not 6.8 units away from 12. No. But on average, all of these are 6.8 units away from 12. And that's what the standard deviation tells you. You're going to need to know the standard deviation for 11.1, which is why we're doing this first. All right, we're going to do this example out of your journal. So up at the top, I've kind of written a brief formula for standard deviation. First of all, this is a lowercase sigma with a kind of a long bar there on the top. So you kind of do it like a sideways 6. Okay, and that's a lowercase sigma. I'll erase my horrible attempts at a sigma there. All right, so here's what we're going to do. We're first going to find the mean, and then we're going to find all of our data points minus the mean. We're going to square them. We're going to add them all up. We're going to divide by how many we have, and then we're going to square root it. If you want to do this as a table, you are welcome to. Okay, the first we're just going to have our x's. We're going to have 18, 11, 15, 20, and 16. So if we add those up, I get 80. So I'm going to take 80 divided by 5, which is going to be 16. So my x bar, or my mean, is going to be 16. And you wouldn't have to write it for every one of them, but since that last table did. All right. So then we're going to do x minus x bar. So the first one is 18 minus 16. So we got 2. 11 minus 16, negative 5. 15 minus 16 is negative 1. 20 minus 16 is 4. 16 minus 16 is 0. Up next, we're going to square those numbers. So we're going to have x minus x bar squared. So that's 4, 25, 1, 16, and 0. Okay, so at the moment, we have these individual parts on the top. So all these squared parts going across the top. So I want to add those together. So I get 46. We're going to divide that by 5, and we're going to square root it. So we're going to divide that by 5, which gives me 9.2. And then if I square root 9.2, I get 3.03. That's my standard deviation. So what this tells me, the interpret part, is that the data typically differs from the mean by 3.03. So on average, the data is 3.03 away from the mean. All right, that's standard deviation. Make sure you do that homework before you venture on into chapter 11. Let me know if you have any questions. Have a good day.